So my name is Gary Clark, KC8TND, and I'm one of the section coordinators for Dayton Skywarn. And we have Brandon here, and Brandon's going to be coming up here in just a few minutes. And we're just going to talk about our partnership that we have with the Wilmington Weather Service here and our role that we had. So this is our how we're broken out here in the Wilmington area, and I say Dayton section there. Dayton section has 15 counties in Wilmington's 52 county area. We're an independent group. We're not an Aries group or a Races group. We don't work for the EMA or activated by EMA. Our solely purpose is to support the National Weather Service. And this is just broken down just a little further that we're, the Dayton area is broken down north and south there. So one of our areas we're talking about is our partnership to save lives. And one of those partnerships, we had a tornado here back 2014 and right here in Greene County, not very far from here. It was in Cedarville. And one of those things that happened was we had a mobile spotter out there in Cedarville, and he relayed to us that there was a tornado on the ground. The tornado with the tornado being on the ground, we relayed that to Wilmington. Wilmington got the messaging out to the media partners. The media partners then broadcasted out. And that top left corner there was where a family of 7 had taken cover and survived a direct hit by an EF3 tornado. So that was thanks to our spotters that were out in that area that confirmed the tornado on the ground. And the messaging was hiding, and we were able to give an exact location where that tornado was at and where it was heading for the Dobbins family farm there, and the Dobbins family of 7 was able to survive. And this is us as net control for that day. And right there at the top 2 screens, you can see the tornado. That was the picture that was sent in that media broadcasted to show the threat on the ground. So then we have 2019. Many of you know there was a multiple tornadoes that happened here in the Dayton area. And I want to see if I can get this to come up now. There we go. Whoop. This is the night of Memorial Day 2019. This is why we tell you not to spot at night. Very dangerous. But you can see the tornado through the flashes of lightning.
Tornado emergency for Montgomery County. The National Weather Service in Wilmington has issued a tornado warning for northwestern Greene County, northeastern Montgomery County, until 11:45 p.m. At 10:59 p.m., a confirmed large and destructive tornado was observed near Troutwood, moving east at 35 miles an hour. Tornado emergency for Montgomery County. This is a particularly dangerous situation. Take cover now. Hazard, deadly tornado. Source, weather spotters confirm tornado. Amateur radio operators have reported a tornado in Montgomery County.
Not sure what happened there. This is
Affirmative. The Dayton Scott, QS1 back to 610. W8OK, KC8LQV. This is KC8LQV up here at North Dixie and Ridge. The Family Dollar Store on the other side, on the east side of the road of Dixie Drive. Small outlet strip mall. Heavy damage. Over. KD80MJ, go ahead. Lots of damage here. It's Westbrook and Seabold. Roofing off, trees 15 inches plus diameter. You look at me, Juliet, we can go back on the airport. Lots of windows broken, lots of damage. Okay, give me the location. Westbrook and Seabold. It's the northwest corner of Trotwood. Seabold, please stop. SEYBOLB. Westbrook and Seabold. Roofs off, trees down, 15 inches in diameter, windows broken out, heavy damage. Thank you. KD80, Juliet, we go back control. W8.
Go ahead.
Hi.
I am at Diamond Mill Road and Little Richmond Road, north of New Lebanon, looking east-northeast. Power flashes, tornado on the ground.
Tornado on the ground. Thank you. PUG, go ahead.
There's a strip mall at the intersection of Siebenthaler and Dixie, and it's basically destroyed. There's a very strong smell of gas, natural gas, in the parking lot. I can't get through to anybody. Maybe you guys can.
This is Dayton Skywarn. A confirmed tornado was located near White Patterson Air Force Base, moving southeast at 50 miles per hour. If you are in the path of this tornado, please take immediate cover. I repeat, a tornado is confirmed located near White Patterson Air Force Base, moving southeast at 50 miles per hour. Please take cover. This is W8OK. Fire station calling. Hotel Foxtrot, please repeat.
Roger, this is Sierra Hotel Foxtrot with a weather report from there is tree debris down everywhere. We're talking limbs anywhere from 4 inches to fire diameter, trees uprooted, power lines down, power poles across the roadway.
Okay, Hotel Foxtrot, what location are you talking about?
Rachel 1.
I am standing at the intersection of Westbrook Road and Rangeview Drive currently.
But I would like
Just
to know
to my west, which would be at between Garber and Cloud is reported on the right side here.
There was a tornado, a fall cloud on the ground north of Cedarville at Weimer and Barber Road. Copy. A tornado on the ground at Cedarville. Repeat the cross street. Weimer Road and Barber Road. Affirmative. Also, we have a tornado. The big supercell appears to be recycling again, and now a tornado is likely occurring near the Greene County, Fayette, Madison County triple point, a few miles north of Jamestown. If you have anybody up there, Jim.
So that was just a brief snippet of our net control station that was going on that night. The tornado that was you heard on there with Trotwood, we verified the tornado on the ground through the lightning flashes. We relayed that to the Wilmington Weather Service. And through that, they issued a tornado emergency. And because of that, between the time that tornado emergency was issued till it's rained EF4 strength into the Dayton area, there was a 36-minute lead time. And there was only one loss of life for the whole tornado, directly lost, and that was up in Salina. A car had went through the house and killed an elderly man that was up there. There was a second loss of life, but it was from the day before. We had a dementia person who wandered off and got lost, and they found her the next day after the tornado went through. She She was found down by the Stillwater River with branches, trees had fallen on her. So it was one direct and one indirect, but it was our partnership that we was able to get the word, we was able to confirm the tornado on the ground, and you've seen all the damage. We also have a good working relationship with our media partners as well. Our net control station, as you saw there, is actually in Cox Media Building, which is Channel 7 to WHIO and a bunch of other radio stations. So we actually have a good working relationship with our media partners. So they actually come to us when they have something as well. Or if they're looking for information, we can get on the radio and ask spotters for that information, and they'll in turn get that word out there. So we're not only working with the Weather Service, we're working with our media partners in order to get the word and the messaging out there to save those lives. And that's all I have. So it was just a brief snippet of our net that night. Brandon's going to go in more detail. He's got some stuff in here from Memorial Day and on the net. Because of the pandemic, we haven't been able to meet in the office with Brandon until this year. So we meet regularly as the coordinators. We meet twice a year with Brandon down to Women's Service office. We meet with the spotter trainings every year. We actively go out to all of our 15 counties and promote the amateur radio service at the spotter trainings. So that's just one of the things that we do to get people active in the program. I'll turn it over to Brandon.
Hey Gary, can you get the presentation back?
Which one?
Oh, it's the one, Kristen.
Yep.
Front slide. So it's done. Close those other things.
Yep, that's what I'm doing it.
Go to slideshow mode from beginning. Okay, from beginning over there.
There it goes.
Is it moving?
I don't know, but it's moving on there.
Okay.
Yep.
Do you want me to do this too?
Yeah.
Okay. Thanks everyone for your patience while we got everything, working up here. I'm Brandon. This is Kristen. We're from the National Weather Service in Wilmington. And as Gary said, Gary from Dayton Skywarn, we definitely have a great partnership, and that partnership was really highlighted of the Memorial Day tornado outbreak. And Kristen and I are going to talk a little bit more about that and a lot of other information later. But it was 4 years ago on Memorial Day. West Central Ohio in particular was hit by numerous tornadoes during the evening hours. It was a significant tornado outbreak, and one tornado that moved through the Dayton-Trotwood area ended up being an EF4 tornado with winds at its strongest of 170 miles an hour. Left a lot of destruction. I was one of the people that did the damage surveys there, and I've been doing this for more than 20 years, and I've never actually seen the widespread destruction face-to-face from a tornado like I saw with the Dayton-Trotwood tornado. So basically, Dayton Skywarn helped to save lives that evening. The National Weather Service were tasked to issue warnings such as tornado warnings. We have great technology like Doppler radar technology that helps us issue those warnings, but ultimately it's the reports that we can put into our warnings that can help us give a lot of lead time, a lot of advance notice for these tornado warnings, especially these tornado warnings that we're issuing for stronger tornadoes. So Dayton Skywarn helped to save lives that evening. Dayton Skywarn provided the National Weather Service with real-time reports of severe weather, including tornadoes. And that information really was the trigger point from us elevating that tornado warning for Montgomery County and surrounding areas to a tornado emergency. And I think we had 8 minutes of advanced lead time before the worst occurred in the Trotwood area of upgrading to that tornado emergency. So certainly, Gary, Dayton Skywarn, we appreciate the longtime partnership that we have. And the National Weather Service definitely wants to recognize Dayton Skywarn with all the efforts they put, not just on Memorial Day evening, but, throughout the year over all these years. And I see, we have other Skywarn people here that certainly help us out when we're in the hot seat issuing severe thunderstorm warnings, tornado warnings, and flash flood warnings. So, Gary, thank you very much. And yes, we've got a plaque here that we would like to give. So Gary, come on back up here. And again, Dayton Skywarn helped save lives that evening, and that's the primary goal of what we do and what they help us do, to save lives through the issuance of warnings with enough advance notice so everybody can take the appropriate action. All right, so Kristen and I are going to tag team this a little bit. So you're going to hear both of us talk. So that's our information up there. Again, we're from the Wilmington office. And so this is going to be kind of challenging. I actually can't see the slides change over here, so I'm going to have to orient my body here. So Kristen, you might wind up doing a lot more talking than me. So this is how we're structured, right? The National Weather Service is a federal agency. We're part of the Department of Commerce. And under the Department of Commerce, or DOC, there's a lot of different agencies, such as NOAA. That's the National Oceanic and Atmospheric Administration. And then under NOAA, you have the National Weather Service. And there are actually 122 individual weather forecast offices across the country. And there's some national centers too. How many are familiar with the Storm Prediction Center, or the SPC? Yeah, that's a good one. They issue the convective outlooks. If you're familiar with marginal risk and slight risk and enhanced risk, the Storm Prediction Center out of Norman, Oklahoma is a national center that issue those. And all the weather forecast offices, those 122 offices, are working with the national centers like the Storm Prediction Center when we're thinking about severe weather and the risk for severe weather, and ultimately whether watches like tornado watches and severe thunderstorm watches are issued. So there's the local weather forecast offices down there, and I think that's a map of the all the different 122 offices there. And if I remember correctly, there's a circle around Wilmington. That is our area of responsibility. Okay, we have 52 counties in parts of 3 states, 52 counties in central and southwest Ohio. We've got some counties in southeast Indiana, and we've got 12 counties in northern Kentucky as well. And essentially, all the weather forecast offices are doing the same thing, just in different geographical locations. And I believe that is a zoomed-in version of our local forecast area. So again, 52 counties in 3 states. And Kristen, I'll let you kind of take it away because I just can't orient it or angle myself enough to see some of the details of the text there.
Well, thanks, Brandon. So essentially, each weather forecast office, the previous slide showed that giant puzzle. So we each have our own area of responsibility. So anything weather or water related within those 52 counties, it becomes our responsibility. And so we will issue forecasts, watches, warnings, advisories for those 52 counties. But of course, we butt up against other weather forecast offices, their own area of responsibility. So when we are issuing those forecasts, those advisories, watches, warnings, we're not only thinking about the meteorology, thinking about, okay, what are we expecting to happen? We are also coordinating those forecasts and that messaging with our surrounding offices. And so we have Indianapolis office to our west, North Webster, Northern Indiana off to our northwest, Cleveland to our northeast, Pittsburgh to our east, Charleston, West Virginia to our southeast, Jackson, Kentucky to our southeast as well, and Louisville to our southwest. So we have to coordinate essentially with all those other weather forecast offices, make sure that our forecasts and our messaging for severe weather is consistent across these kind of artificial boundaries that we create. And so to our southeast, you see the Jackson, Kentucky office. They're actually considered our sister office. So in the event we would need to, seek shelter from a tornado ourselves, they can assume warning responsibilities for us and vice versa. In fact, just on Tuesday, they had a tornado warning that they issued essentially for themselves in Jackson, Kentucky. And so we had to kind of be prepared to take over warning responsibilities if they needed to take shelter from that particular storm. So it's a lot of collaboration, making sure that our message is unified so that the public knows what action to take.
Well, I was able to get past a couple of slides, and now the down button does not want to work to move the slide.
There you go.
All right, back on track.
All right. Perfect. So this is kind of an aerial view of our campus right outside Wilmington, Ohio. You can see, of course, the big feature that you might notice right off the top is our radar. Our radome is atop about 100-foot tower or so. And we'll talk a little bit more here in just a little bit about what's actually going on inside that golf ball type structure. But of course, you can see our office building as well. And the office was opened in the early 90s, 94, and was a consolidation effort in the Weather Service to consolidate some of the other local offices, one which was located in each of the metropolitan areas of Columbus, Dayton, and Cincinnati. So those offices kind of consolidated, combined into the one office in Wilmington, Ohio. And of course, one thing you might think right off the top of your head, well, Wilmington is kind of equidistant between Cincinnati, Columbus, and Dayton. And that was strategic because we wanted our radar, which is right there on site, to have good scanning resolution over the three metropolitan areas. So that's one of the reasons why Wilmington was chosen in this consolidation reorganization effort of the National Weather Service in the early 90s. So this is a picture of our radar at nighttime. And so throughout the mid-90s, progressively, the Weather Service offices, which again, kind of all merged into the Weather Forecast Office from Wilmington, they progressively closed. And so those warning and forecast responsibilities were handed over to this new consolidated offices. And so with the closure of the Weather Service office in Columbus in 96, that kind of marked the complete transfer of all of the responsibilities over to this one centralized location and office. And our office is actually fairly unique too, that we are co-located with what is called a river forecast center. There are only 13 river forecast centers across the entire country. So our office is co-located with one of those centers, and they will then issue river forecasts, monitor river levels, essentially for the entire Ohio River basin. And of course, then that impacts what's going on downstream once the Ohio reaches the Mississippi. So they have a much larger area of responsibility than we do, but our office is actually one of the bigger weather forecast offices in the entire country because we are co-located with this river forecast center. And they have both meteorologists and hydrologists on staff there. And we coordinate a lot when we're expecting flooding, river flooding. We rely on them for their expertise there. But at the end of the day, we are still the ones issuing the warnings for flood warnings, like aerial flood warnings and river flood warnings as well. So our building, of course, we're staffed 24/7, 365. The weather does not take a holiday off, and that was especially evident on Memorial Day in 2019. Of course, our staffing levels are going to differ depending on the situation. They're going to vary from day to day, from time of day to time of night, depending on the weather situation. Of course, a day like today, we have lots of blue sky, lots of sunshine. We might have as few as 2 people in the office, and especially since we are not expecting any severe weather anytime soon, our typical base staffing is about 2 to 3 meteorologists during the day in our office. And then, of course, we have day shifts followed by evening shifts, followed by overnight shifts. But we will always have 2 forecasters on staff. So this is a look at our operations area. Of course, you can see in this picture, no work is being done, but I promise you there is someone there right now. In fact, again, 2 to 3 meteorologists, even during the quiet weather, because not only do we issue warnings, issue watches, we also issue things like aviation forecasts for 6 of the area airports. And even though, on a lot of days in the winter might seem like there's not a lot going on because it's cloudy, but clouds and low visibility, of course, that impacts the aviation industry, and that's when the aviation forecast desk can be particularly busy. So there's always something to look at, even on these quieter weather days.
I'm pressing the button, I'm telling you.
Here you go. All right, perfect. So this is kind of a look at our operations area if we were expecting active or severe weather. Of course, we all have our own assigned duties when we're coming in for shift. And that's one of the main responsibilities of a shift supervisor, is to coordinate exactly, A, how many people we're going to need and what kind of responsibilities and roles we need to fill leading up to a severe weather event. So, of course, we have our public service desk. That's the desk that might do a special weather balloon launch ahead of severe weather. That's the desk that is probably going to be one of the first to answer our public phones. And, of course, the desk that might be handling some of the social media posts, the social media content that comes out of our office leading up to active weather. Of course, then you still have someone handling the forecast, even when there are storms on the radar. Both the public forecast and the aviation forecast. And then you'll have someone, probably not during severe weather, but someone who's also taking a look at what we call the long-term forecast. So that's anything really essentially beyond 48 hours. So we have someone kind of looking at the next 48 hours. And of course, the most detail will go into those forecasts. But then we have someone who's looking kind of broader range, longer range. And of course, as you go out into the future, the weather forecast becomes a little bit less certain. So we tend not to put as much detail because there are uncertainties both in time and space of how the weather is going to evolve in the future. This is a look at our computer system. Usually we have 4 or 5 different screens, and our computer system is called AWIPS. Stands for Advanced Weather Interactive Processing System. So we can view pretty much any type of data we want on these screens, whether it's satellite data, radar data, observational data, rainfall data, anything that we would want to look at, we can pull up on our system, and we have a number of screens to be able to look at things simultaneously. And of course, we have then a typical PC to be able to do things like social media and to interact with our public webpage. All right, so retrieving and collecting data and observations. Like I mentioned, we are what's called an upper air site. We launch weather balloons, we prep it and launch it twice a day. This time of year, it's 7 a.m. and 7 p.m. It's basically 0 and 12 Zulu or UTC. And so we will do that at least twice a day. If we're expecting severe weather, we can prep and launch a supplementary weather balloon. And that will give us an updated a profile of the atmosphere. So we attach an instrument to the weather balloon, and it sends back to our office via a radio signal data on temperature, moisture, air pressure, wind speed, and wind direction. And that data tells us everything that we need to know, or essentially gives us a really good snapshot of what we need to know regarding storm potential, storm severity potential, and the possibility of storms developing. It provides a wealth of information, and that's real-time data. That's not computer-generated data. That is actually observed data, and that's the best data to look at because you can actually see visually how the environment is evolving from the morning launched at 7 a.m. to maybe the afternoon at 3 or 4 p.m. Of course, our radar is a huge tool for us. When we are anticipating severe weather, one of the roles that we will staff is called a radar operator. In a typical severe weather event, we will have 2 radar operators. Sometimes it could be as many as 3, depending on the scope of the storm coverage and storm severity. And so their entire job is to look at radar data. They are not answering the phone. They are not sometimes even eating snacks or anything like that. They are solely interrogating radar data and issuing warnings based on that data that they receive, as well as the reports that we get from the public and from amateur radio alike. And then, of course, looking at surface observing stations, whether that be an observation from someone's weather station they might have in their backyard, or one of the more sophisticated systems like you see pictured here. We use all of that data to diagnose the environment and determine exactly what the likelihood is for storms. And we kind of put all that information together to help deliver a consistent and accurate message. So this is a picture of our radio sonde there in the bottom left. If you stop by our booth, you might have already seen that already. That's the instrument that will essentially measure temperature, moisture, and send that data back to us via a radio signal. And so our computer will decode the data, and it has an internal GPS component, so we can detect its change in location over time, which of course that gives us the data we need to know about wind direction and wind speed. And then we can also determine the air pressure from the altitude. And so that's a picture of our balloon in its inflation shelter with the parachute. The balloon will go all the way up to, a lot of times, 110,000 feet above the ground. Takes about 2 hours for that balloon to ascend all the way through the atmosphere. And then it gives us the data that you see there on the right. It might look like random squiggly lines, but that data tells us everything that we need to know about the potential for storms. The red line is the temperature, again, going up through the atmosphere from the ground on the bottom up to about 100 millibars on the top. And then the green is the moisture content. So essentially, very simply, if the red and green are close together, that typically means you have a moist profile and typically would indicate the presence of clouds. So there's a look, that picture on the left, a look inside our radome. There's a big satellite dish rotating 360 degrees, 24/7, 365, we hope. And it is providing us a wealth of information. The 2 main products, the 2 main data sets that you are likely familiar with and that we certainly use the most are what we call reflectivity and velocity. So reflectivity is essentially the amount of energy that's coming back to our radar. It's a proportion of the signal that is returned from objects in the sky, whether that be raindrops, hailstones, even things like birds and insects. And the really cool thing is we can use the phase shift in that returned energy to determine whether the object is moving away from our radar or toward our radar. So essentially, we can see, at least estimate, wind speeds within a thunderstorm. We can estimate airflow within a thunderstorm and outside of a thunderstorm. And that's really helpful for us to determine whether a storm is strengthening or weakening, depending on whether the air is coming together, we call that convergence, or whether it's moving apart from each other, which is called divergence. So, and we can use that along with storm relative motion, which essentially is a data set that will subtract the storm motion itself so that we can better isolate what low-level circulations might be within the storm. That might give us a heads up of when a tornado, might be forming in the near future. So this is a very simple animation of what our radar is actually doing. It's sending out a pulse of energy, and bits and pieces of that energy will reflect back to our radar from whatever happens to be in the sky at the time. And so that is what makes up the reflectivity data that you see. And then, like I said, you can detect velocity, whether the object is moving directly toward the radar or away from the radar. But that is essentially what our radar is doing to generate those images that we're so used to seeing. This image on the left, that's a scary looking reflectivity image from the Memorial Day outbreak in 2019. And that is, in fact, the supercell thunderstorm that was producing the tornado in the Dayton area on that night. You can see it has a well-defined hook feature, and that circular enhancement of reflectivity at the end of the hook, we call that a debris ball. And that lets us know that debris is being lofted in the air from the tornado. And our radar is actually picking up on that. So whether it be insulation or shingles, anything that might be lofted into the air from a tornado, if it's high enough, our radar might be able to see it. And one of the great things about our radar too is we can see vertically into a storm. We can get a three-dimensional view of what the storm's doing. And based on our training, we can then determine whether a storm's likely weakening or whether it may be strengthening. So we put all of these pieces together. The environment, looking at surface observations, the storm structure itself, and we determine if a storm is likely to be severe, likely to produce a tornado, then a warning is going to be needed. And so essentially we will draw on our computer screens where the center part of that threat area is. We will track that feature through time, and then we will draw essentially a box or a polygon around that storm. And so the information that you see in a warning, a lot of that information is automatically derived from where we are drawing our polygon and how we are tracking the storm. So the storm motion, the areas that are going to be impacted, all of that information falls out of this polygon right here. And so that is kind of all an automatic process once we determine where the polygon is placed. Of course, we always recommend having 3 different ways to receive warning information, because one of them might fail. If you're relying on, say, TV and your power goes out, how are you going to be warned? How are you going to be alerted that a storm is approaching your area? We ask the question a lot when we're speaking, in the public, especially at nighttime. What is going to wake you up to get you to go to a safe place, to get you to go to an interior room or the lowest level of your home? What is that going to be that's going to wake you up? Obviously, NOAA weather radio is one of the most reliable ways. It, of course, makes a tone. It's battery activated, so it doesn't rely on electricity. And certainly it's one of the most reliable and the fastest way to get warning information for your particular location. So we always recommend staying weather aware, and part of that is by taking a look at our webpage, weather.gov/ILN if you live locally. But really, if you type in weather.gov, if you're not local, you just type in weather.gov. The main page has a large map. You click on the map, and it will take you to the Home Forecast Office webpage. And so you can access all of the information that they are distributing from each office's homepage. And so we recommend, just for general awareness, to stay up to date with what is going on from a forecast perspective, checking your office's homepage, reading the hazardous weather outlook. Okay, is there any potential for strong to severe storms in the next 5 to 7 days? So that's one of the ways we recommend staying weather aware. So we get storm reports from a variety of locations and sources. Amateur radio is one of the best ways that we receive storm reports. We also have a vast network of storm spotters who have attended one of our spotter training courses. And of course, through social media, Twitter, Facebook, of course, we can have reports emailed to us. We can have reports called to us, especially the more urgent ones like tornadoes and funnel clouds. Certainly, we don't want to be reading that on a social media post 3 hours after the fact. We want that information called into us directly. This is a picture here of the Skywarn station at the National Weather Service in Wilmington, Ohio. And actually, the picture on the right is the more updated look there. And so what happens is when we have a severe thunderstorm or tornado watch that is issued for part of our area, and that is coordinated with the Storm Prediction Center and the local offices, we will activate or request activation for the different Skywarn networks. And if we go to the next slide here, there's kind of a look at the networks within our 52 county warning area. And so it's so important to be able to have kind of the net control in Wilmington, in Clinton County, sitting a mere 6 or 8 feet away from our warning operators, so that when amateur radio has that report of the tornado on the ground on Memorial Day night, that information is relayed face-to-face directly with our radar operators so that we can get that information out to the public as soon as possible. Because research has shown time and time again, the public is much more likely to take action if they know that the warned hazard is already occurring. So having that information that we have trained spotters in amateur radio reporting a tornado on the ground in Dayton, Ohio, we don't know how many lives that may have saved. We don't know how many people took action based on that information. But you can bet that at least there was someone that took action. They see that that tornado was actually reported on the ground by trained spotters and amateur radio, and they took action to protect themselves by moving to an interior location or a low level in their house. This is a picture of the amateur radio setup out of Dayton. That's out of Columbus, Cincinnati. And so essentially, this is the process of how we, on Memorial Day night, received confirmation that what we were seeing on radar was as bad as it seemed like it was on radar. I happened to be working the night of Memorial Day, and I can tell you that spotting tornadoes at nighttime is incredibly difficult, incredibly challenging. It is difficult for us to get ground truth of a tornado on the ground at nighttime. But in this case, Dayton Skywarn and the various amateur radio personnel that were activated and working that night, they helped save lives because they got that information to us very, very quickly so that we could upgrade from a tornado warning to a tornado emergency, which of course is the highest level urgency product that the National Weather Service issues. And again, it's all about that partnership to save lives. It's the National Weather Service. It's our spotter network. It's the amateur radio network, all working together to help protect communities like happened in Montgomery and Greene counties on Memorial Day of 2019. So this is a kind of a complex radar image here. So on the top left, that radar image, that's your reflectivity. Again, it's just zoomed in to the hook feature and the debris ball that is at the end of the hook feature. The top right is the velocity data, showing velocity air moving in two different directions at very high velocities right next to each other. That tells us that there is a very, very strong, intense circulation within that storm. The bottom left is something we call correlation coefficient. It essentially will tell us the nature of the pulse, the nature of the energy coming back from the pulse. How does that differ from one pulse to another? And when there's low correlation, that means that it is seeing objects of different sizes and different shapes. And the reason for that is when you have a debris ball, you have low correlation coefficient because some of those objects that's returning energy to our radar, it might be insulation, it might be shingles, it might be small pieces of wood, which of course all have different sizes and shapes. So we can use that reduction in correlation coefficient to also confirm that what we are seeing here is likely debris on our radar. And the bottom right is something called differential reflectivity. It's telling a similar thing to correlation coefficient, telling us that there are different shaped objects that are returning energy to the radar within that particular location. So we used all of this information as well as the reports that we got from Dayton Skywarn that night. And we took all of this information together. That in exceedingly rare conditions, if there is an extreme risk to life and property, we can issue a tornado emergency. So we have to ask ourselves, was this a populated area? Absolutely it was a populated area. It was the Dayton metro area. Did we have a confirmed tornado? Yes. Dayton Skywarn told us there was a confirmed tornado on the ground in Trotwood. Do we have certainty of a strong tornado? Absolutely. Those velocities on that velocity image tell us that it's an intense circulation. So we had all three things. And at 10:57 p.m. on Memorial Day 2019, our office issued just its second tornado emergency on record. And so that was because of the reports that we were able to get from Dayton Skywarn and the amateur radio networks. And there it is, 10:56, A confirmed large and destructive tornado was located over Trotwood. That warning is coming across your phone, or that warning is coming across the TV. You are not going to treat that like any other tornado warning. You are going to seek shelter quickly. And we have to be able to communicate the urgency of that situation as quickly as possible to as many people as possible so that they can take action to protect themselves. So for storm reports, what do we ask from our storm spotters? Well, they're trained spotters. They went through our basic training course, and depending on where you live in the country, your local National Weather Service office may have a slightly different variation of the same training course. But essentially, they are all the same, and we want to know, okay, where are you located? What are you observing? And are there any uncertainties in what you are relaying to us? We want to know uncertainties because we recognize that not every situation is going to be clear-cut. Not every cloud formation is going to be definitely a funnel cloud or definitely a tornado. We understand that there are a number of uncertainties when reporting. So that's the information that we're looking for from our spotters when they're calling in a severe weather report. Of course, any wall clouds, funnel clouds, tornadoes, we want to hear about those. Any large tree limbs downed or any trees snapped. We want to hear about that. Any flood damage. You know, are you observing flooding? Is the water in your area, is it rushing across the road or rushing across your yard? We want to know, of course, hail of at least 1/2 inch in diameter, even though the severe threshold, according to National Weather Service criteria for a severe thunderstorm, is 1 inch diameter hail. We want to know about 1/2 inch because, of course, the hail has to be 1/2 inch before it can get to 1 inch. And so we want a heads up if someone's seeing 1/2 inch hail, something we would want to know about. Of course, we've talked with several folks that have their own personal weather stations. Anything with a rain rate in excess of 1 inch an hour, that's a pretty heavy rain rate. Of course, in thunderstorms, you can get 2+ inches an hour. And typically that is rain that would be heavy enough to potentially cause flooding, even if the ground is relatively dry. Of course, we don't ask our spotters to report lightning, even though it can be dangerous if you're outside. This graphic kind of references hailstone sizes. We recognize that it might be difficult to estimate the size of a hailstone. It's difficult to estimate the diameter. But if you can relate it to one of these commonly known items, like small hail is like pea-sized hail. If you can relate it to the size of a coin, like a penny or a dime or a quarter, quarters are about 1 inch in diameter. So therefore, severe hail is about the size of a typical quarter. Of course, once you get into the realm of sports, like golf balls and baseballs, then you're talking very large hail. And we always ask this question. We don't know what size marble you might be talking about, so please don't report marble-sized hail. We get that a lot. We get grape-sized hail, too. We get that reported to us a lot. In terms of wind, you know, what we're looking for is essentially what happened. We're not looking for an estimate of the wind speed. If it was severe wind, chances are there is some sort of damage in that area. Not always, but chances are good that there is some sort of large tree limb down or some sort of tree that was snapped. And so determining what type of wind speed caused the damage can be very difficult. We always ask our spotters to let us determine what caused the damage, and you just report the type of damage that you've seen to us. Of course, phone and amateur radio, those are the two best ways to get information, to get reports to the National Weather Service as quickly as possible. Again, we do not want to see a picture of a tornado coming into our Twitter feed 3 hours after the fact. We want to have those more urgent reports sent to us as quickly as possible. The National Weather Service, with our various partners, both at the state level and local level, we're working toward building a weather-ready nation. Essentially, that means building communities that are resilient in the face of increasing vulnerability due to extreme weather, water, and climate events. And so we are providing a variety of what we call decision support services. That's targeted weather information to a variety of partners so that they can make the best decisions regarding public safety. And we have to promote this Weather Ready Nation initiative, this idea of resilient communities. We have to promote that whenever we are in the community, whenever we're talking to members of the community. And that includes social media outreach, media interviews, having our data easily accessible by all types of people, all types of vulnerable communities, making sure that the data, those warnings, that they're getting to the people that need them the most. And so it's all part of trying to build resilient communities due to, you know, the increased vulnerability due to extreme weather events. At this time, I'd like to pass it back to Brandon and then potentially open the floor to a couple questions.
Yeah, we definitely want to take your questions. I want to give an extra thanks to Kristen here too. We had actually planned on tag teaming this presentation, so you would have heard me talk a lot more, but the slides aren't changing here, so I can only see the slides over here, which there's no way I could do that. So Kristen ended up doing a lot more than I think she expected, and she did a great job. Thank you very much, Kristen. So this is the fun part, and Gary's coming back up here as well. You get to ask us some questions, weather-related questions, please, and just fire away, as Pat Benatar would say. And you have to speak up.
Yeah, so the question was, what happens to our weather balloons when they go up? Well, essentially, so at our office, we have a hydrogen generator, so they're filled with hydrogen, and we release them. They're not on a tether. They will go wherever the wind takes it, essentially. And eventually, as it goes up, the air pressure will decrease, and so the balloon will continue to expand, expand, expand. Believe it or not, getting about 20 feet in diameter before it ends up bursting. And we have that parachute that will allow the balloon plus the parachute plus the weather instrument to glide gently back down, and it will land wherever the wind will take it. And again, it bursts at about usually above 110,000 feet above the ground level. So that's into the stratosphere. These balloons get really, really high. Of course, for meteorologists, we are only concerned about the data in the troposphere. So generally, the lowest 30 to 40,000 feet, that's the data that we're most concerned about. But it keeps giving us data well into the stratosphere. Yes.
The radio package on the balloon, does it ever get it back?
The question is, do we ever get the radio sound on the balloon back?
So we just transitioned to a new type of radio sonde. The old type actually came with a self-stamped envelope, kind of a baggie that you could wrap the instrument up and send it back to one of our reconditioning centers. The new types do not have a way to actually send it back to us. So if you find one in your yard, maybe it's a fun souvenir to hold on to. I know I probably would as well, because it's kind of fun to have a weather instrument in your yard. But they're essentially one and done use instruments from our perspective. So that's a great question. The question was, are there navigation lights on the balloons? Some offices do have those. They will put like a light stick on the balloon train, as we call it, like attached to the balloon, so that it can be seen. We do not have that at our office. We do coordinate with the local tower at the Wilmington Air Park, make sure that there's no increased air traffic that's taking place, no backlog of planes coming in or taking off right as we're about to launch the balloon. So that provides us a little bit of safety, making sure that there's no interaction between our balloon and any potential aircraft. Yeah, so it said that there were stationary red and green lights maybe in the sky. Certainly not our weather balloon. If we attach a light stick to it, it's a simple yellow light stick that only has about 2 hours worth of light. Unfortunately, yes.
I think it's just a UFO.
Yeah. Yes. Yeah, that's a great question. So the question is, if you're not around here, how do you find what weather station, weather office you might send a report to? And that's a great question. So If you go to weather.gov, that is our national webpage, and say you're from northern Georgia, you click on the map, and it will take you to the office that serves northern Georgia. And then at the bottom, there will be a phone number and an email contact for you. And you can get in contact with the office and find out what their preferred method is for reporting to them. Because each office might have a little bit different preferred reporting method depending on where they're located. Yes. Sorry. Uh-huh. Yeah, so I think I heard the question, is there a predictive software for, severe thunderstorms like there are for hurricanes? So essentially we rely pretty heavily on just our computer models. They're just the general weather models. The data from our weather balloon will feed right into those weather models. So we can track anything from hurricanes to winter storms, to ice storms, to severe weather outbreaks, based on the various solutions that weather models are giving to us. And that information is actually all available online, because these weather models are funded through the National Weather Service and funded by the taxpayer. So all of that weather model data is available online, kind of as an open source. So if it interests you to take a look at what weather models look like, I invite you to visit weather.gov, and I know there are links from that main webpage to take you to these individual weather model data sets. And of course, those data sets will update depending on the type of weather model. Some weather models will send us new data every hour, but more commonly every 6 hours. Yes.
Look at the chart up there, and it's all nothing about National Hurricane Center.
Yes, the question was, you didn't see the National Hurricane Center mentioned on our kind of flow chart of organization. Yes, that is one of the national centers. So it's basically right there with Storm Prediction Center. We just didn't have enough room on the screen to put it there. But you might have also heard of the Weather Prediction Center, Space Prediction Center, Ocean Prediction Center. All of these national centers kind of have more specialized areas of expertise. And certainly at the National Hurricane Center, their area of expertise is forecasting not only where a hurricane's going to go, but how strong it's going to get before it makes landfall. Yes. Yeah. Yeah, so I'll kind of just generally repeat. If you want to track the radiosondes, their frequencies are known at our office. It's 403.81 megahertz. And there is a website that you can go and actually track the instruments as they're ascending and then also descending from their flight. So if that's something that interests you, certainly that information's available online.
Got one over here.
Wildfires?
Yeah, do we track them?
So yeah, certainly we partner a lot with the various forestry agencies. in terms of trying to contain wildfires. And the Storm Prediction Center will actually issue fire weather outlooks, depending on how dry and windy the conditions may be. And we actually have at our office a forecaster who is specially trained to supply weather information on site during wildfires, and he's called an incident meteorologist, or IMET. And so during wildfire season, this particular forecaster might be deployed to Alaska. He's been deployed to Washington, Idaho, wherever there may be a fire, because of course, as the forestry folks are battling that fire, trying to contain it, weather, of course, plays a crucial role in trying to determine where to position folks. And so that's a big part of the National Weather Service mission as well. We support the Forestry Service by supplying incident meteorologists when they're needed.
Probably have room for one or two more if there's any others out there. If not, you can always, come on up after. I see one more hand down here.
Yeah, so the question is there any sort of product to be able to view our radar data? And you can go to our website. The radar data is right there. It's on a map. You can zoom in and zoom out, choose the different, whether you want to look at reflectivity, velocity, storm relative motion. So that's all available on our website. And then, of course, there are some private vendors that take that same data and they might display it in a slightly different way. But that data is coming from our radar. If you're in the local area, of course, we have a network of radars across the country. But that data is all available on weather.gov. And you can zoom into any part of the country, see what the radar is, and it'll update. You can put it into motion, show an animation. So much of the data, I don't want to say all, but much of the data that we're looking at when we're issuing warnings is also available online, free of charge, because it's part of weather.gov.
All right, well, we'll hang out here for a few minutes up here. Thanks everyone for attending this forum presentation. Hopefully you enjoyed it and got something out of it as well. And enjoy the rest of the day.